So let's take a look at calculating area between two curves. So looking at number 1, in order to find the area between the lines y equals x and y equals half x plus 1, we need to set up our formula. And the formula is pretty simple. The area between these two curves is equal to the integral of top curve minus bottom curve. As you can see, the top curve is this one, so that is y equals half x plus 1. And the bottom curve is this curve, which is y equals x. So minus x. And in addition, I also need to find out my x bounds. So from which x values is the area being shaded? So obviously we know that the first x bound is 0. So we can put 0 on the bottom. And we need to know what this one is. And that's right where the two curves intersect. So in order to find the intersecting point, all we have to do is set these two equations equal to each other. So I can do x equals half x plus 1. When I subtract half x, I get 1x minus half x, which is just half x, equals 1. And then I can divide by 1/2, and dividing by 1/2 is multiplying by 2, and 1 times 2 is 2. So at x equals 2, that's where they intersect. So I can put from 0 to 2. So now I can evaluate my integral. I can actually simplify half x and x since they're like terms. So 1/2 x minus 1x is negative 1/2 x. And we have a plus 1. And now when I integrate, there's a plus here, so I can separate into two integrals. So from 0 to 2, the negative 1/2 is a constant, so it can come out front. Put negative 1/2 times the integral from 0 to 2 of x dx plus the integral from 0 to 2 of just 1 dx or just dx. So in order to integrate x, we add the power by 1 and divide by the same power. So just using the power rule. So x squared over 2 plus the integral of dx, which is just x. So a little bit more simplification. We get negative x squared over 2 times 2, which is 4, plus x. And for now, we gotta put in our bounds. So from 0 to 2. First I plug in the top bound. So when I plug in 2, 2 squared is 4, and negative 4 over 4 is negative 1, plus 2. We have minus when I plug in 0. 0 squared is 0, 0 over 4 is 0, plus 0 is 0. And so negative 1 plus 2 is 1, minus 0 is just still 1. And that's our final answer. So looking at number 2, there isn't necessarily a top curve minus bottom curve here. Instead, there is a right curve and a left curve. So unlike the previous problem where top curve minus bottom curve, we had to use all x values. In right curve minus left curve, we have to use y values. So in order to do that, we also have to change our equations so that they're all in terms of y. So first, let's start with y equals x squared. I can just square root both sides, and I get the square root of y equals x. And for y equals 2 minus x, I can subtract 2, so y minus 2 equals x, or negative x, and I can divide by negative 1. So we get x equals 2 minus y. So I'm just going to put those on the side here. So x equals the square root of y, and then x equals 2 minus y. So now I can set up my integral. So we have the integral of the right curve minus the left curve. And the right curve is y equals 2 minus x, which is in terms of, when we put in terms of y, it's going to be 2 minus y, minus the right curve, which is the square root of y. dy. And we also have to put in our two y bounds. So we're not doing x values, we have to do y values this time. So we obviously start at the y value of 0, so that's our bottom bound. And our top bound is where they intersect. So we can actually just set these two equations equal to each other. So x squared equals 2 minus x. And so we can put x to the other side, add x to the other side. And we can subtract 2 to the other side as well, set it equal to 0. It's a quadratic equation, so when I factor, I need two numbers that can multiply to -2 and add to 1. So we have x minus 1 and x plus 2. And that means x is going to equal 1 and -2. Well, right now we only need the x value of 1 because -2 is over here and we're not looking for that. So when I can plug in 1 to any of these equations to find the y bound. So let's just plug it into this one here. So y equals 2 minus 1. So the y coordinate is going to, or the y value where the intersect is going to be 1. So those are my bounds from 0 to 1. And so now what I can do is evaluate. The integral of 2 with respect to y is just 2y. The integral of y, obviously using the power rule, is y squared over 2 minus the integral of the square root of y, or I can change that to y to the 1/2 power dy. And in order to evaluate the integral of y to the 1/2, we can use the power rule once again, so add that power by 1. The 1/2 plus 1 is 3/2, and we can divide by 3/2 or multiply by 2/3. And so we'll get 2y minus y squared over 2 minus the integral of y to the 1/2 dy, which is 2/3 y to the 3/2. And our bounds are from 0 to 1. So when I plug in 1, I get 2 times 1, which is 2, minus 1 squared, which is 1, over 2, which is 1/2, minus 1 to the 3/2 is 1, times 2/3 is 2/3, minus, when I plug in 0, the bottom bound, I get 0 minus 0, and once again minus 0. So that can just be cancelled out. 2 minus 1/2 is 1.5, or in other words 3/2. And we have minus 2/3. So finding the common denominator, I can change 3/2 to 9 over 6. I can change 2/3 into 4 over 6. 9 over 6 minus 4 over 6 is equal to 5 over 6. And that is the final answer.